Alessandro Volta. Alessandro Volta was a physicist, a chemist, and a pioneer of electrical science. He is most famous for his invention of the electric battery. In brief, he invented the first electric battery, which people then called the voltaic pile, in 1800. Using his invention, scientists were able to produce steady flows of electric current for the first time, unleashing a wave of new discoveries and technologies. He was the first person to isolate methane. He discovered methane mixed with air could explode using an electric spark. This is the basis of the internal combustion engine. He discovered contact electricity resulting from contact between different metals. He recognized two types of electric conduction. He wrote the first electromotive series. This showed from highest to lowest the voltages that different metals can produce in a battery. He discovered that electric potential in a capacitor is directly proportional to the electric charge. In recognition of Alessandro Volta's contribution to science, the unit of electric potential is called the volt. Alessandro Volta was born in Como, Lombardy, Italy, on February 18, 1745. His family was part of nobility, but not wealthy. Until the age of 4, he showed no signs of talking, and his family feared he was not very intelligent or possibly dumb. Fortunately, their fears were displaced. His father died leaving unpaid debts when Alessandro was 7. The young Alessandro was educated at home by his uncle until he was 12 years old. He then started studies at a Jesuit boarding school. The Jesuit school charged no fees, but pressurized him to become a priest. His family did not want these and withdrew him from the school after 4 years. Volta then studied at the Benzi Seminary until reaching 18 years of age. Volta's family wanted him to become a lawyer. Volta had his own ideas. He was interested in the world around him and he wanted to be a scientist. Although as a child he had been slow to speak Italian, Volta now seemed to have a special talent for languages. Before he left school, he had learned Latin, French, English, and German. His language talents helped him in the later life when he traveled with the aim of discussing his work with scientists in Europe's centers of science. At the age of 18, Volta was bold enough to begin an exchange of letters about electricity with two leading physicists, John Antonio Nollet in Paris and Guillaume Battista Beccaria in Turin. Beccaria did not like some of the Volta's ideas and encouraged him to learn more by doing experiments. When he wrote his first dissertation, Volta addressed it and dedicated it to Beccaria. You must be ready to give up even the most attractive ideas when experiment shows them to be wrong. In 1765, Volta had reached 20 years of age. His wealthy friends Giulio Cesar Gattoni had built a physics laboratory in his home. For several years, he kindly allowed Volta to do experiments in his laboratory. In 1765, Volta wrote his first scientific paper, which he addressed to Guillaume Battista Beccaria about static electricity generated by rubbing different substances together, that is, triboelectricity. In 1769, Volta published a dissertation titled On the Attractive Force of the Electric Fire, and on the phenomenon dependent on it, which he sent to Beccaria. He discussed his idea on the causes of electrical attraction and repulsion and compared this with gravity. He set out his position that, like gravity, static electricity involved action at a distance. The main scientists influenced his thinking were Isaac Newton, Roger Boscovich, Benjamin Franklin, and Giambattista Beccaria himself. In 1771, Volta read Joseph Priestley's 1767 Review of Scientific Research on Electricity. He learned that some discoveries he had made recently had already been made by others. In 1774, Volta began work overseeing schools in Como. He said that teaching in Como's classrooms should be modernized. He wanted the children to spend more time learning science and modern languages. In 1775, Volta began teaching experimental physics in Como's public grammar school, where he worked until 1778. In 1775, Volta wrote a letter to Joseph Priestley. He explained how he had invented a device that produced static electricity. The electricity could be transferred to other objects. We call this device the electrophorus. Volta wanted to know if the device was a new invention. Priestley told him Johann Wilke had invented such a device in 1762, but Volta had invented it independently. Priestley encouraged Volta to keep up his interesting research work. In 1776, aged 31, Volta was the first person to isolate methane gas. He discovered that a methane air mixture could be exploded in a closed container with an electric spark. An electrically started chemical reaction like this would later be the basis of the internal combustion engine. In 1776, Volta suggested that a sparking apparatus he used to explode methane could also be used to send an electric signal along a wire from Como to the city of Milan. In 1777, Volta invented a much better eudiometer than any that had gone before. An eudiometer tests how much oxygen is present in the air to determine how good for breathing it is. Volta's eudiometer was superior to others because it uses hydrogen as a gas reacting with oxygen, giving a clean, reliable reaction. The reaction was also cleanly stated using an electric spark. A eudiometer worked on the basis that the volume of hydrogen gas in it decreases after sparking because the hydrogen reacted with oxygen gas to make water. The decrease in volume was proportional to the amount of oxygen present in the air. In 1777, Volta set out on a scientific journey to Switzerland and France. He met other scientists and showed them his innovations in electrical instruments. He also traveled with the purpose of making his name better known outside Italy. In 1778, Volta was appointed to the chair of experimental physics at the University of Pavia, about 55 miles, that is, 85 kilometers from Como, a position he would hold for over 40 years. In 1778, Volta discovered that electrical potential we now often call the voltage in a capacitor is directly proportional to the electrical charge. In 1781 to 1782, Volta traveled around most of Europe's major scientific centers, including the French Academy in Paris, demonstrating his electrical instrument and inventions to eminent people such as Antonio Lavoisier and Benjamin Franklin. Volta was beginning to become well known outside Italy. In 1782, Volta wrote about a condenser he had constructed. Today we call it a capacitor, to collect and store electric charge, and how he had used it to study a variety of electrical phenomena. In 1788, Volta built increasingly sensitive electroscopes to detect and measure the effects of electric charge. In 1790, Volta carried out experiments on the behavior of gases. He found an accurate value for air's increasing volume with rising temperature. In 1791, recognizing that he had become one of Europe's foremost electrical scientists, Volta was elected to a Fellow of the Royal Society of London. In 1794, at the age of 50, Volta was awarded the Royal Society's top prize, the Copley Medal, for the contributions of scientific understanding of electricity. Volta did not set out to invent the battery. His experiments in this area were actually performed to show the claims of another scientist were wrong. That scientist was another Italian, Luigi Galvani. Galvani discovered that contact between frog's leg nerves and different metals caused the legs to move. We now understand that he had created an electric cell. The frog legs acted as the electrolyte. Galvani was a professor of anatomy. In the late 1780s, he noticed that a spark of a static electricity carried by a metal scalpel touching the nerves of a dead frog while the legs lay on metal caused the legs to move. This was an amazing discovery. Animal movement was based on electricity in some way. In 1817, this inspired Mary Shelley to write Frankenstein. In his novel, a creature made of monstrous mixture of body parts from dead body is brought to life by Dr. Frankenstein using electricity from a lightning storm. In 1791, Galvani announced his discovery of animal electricity. He believed that animals generated electricity in their bodies and that the fluid within their nerves carried electricity to the muscles, causing movement. He believed that the electricity from an outside source released the flow of electrical fluid from the nerves, causing the muscles to jump. He also believed that animals such as electric eels could build up extra amounts of this fluid and use it to deliver electric shocks. Galvani concluded that animal electricity was similar but not identical to static electricity and was a unique property of living things. In 1792, Volta said that the animal part of Galvani's animal electricity was not needed. Animals merely responded to normal electricity. There was no difference between animal electricity and electricity. Volta performed various experiments on frogs' legs. He found the key to getting them to move was contact with two different metals. Contact with pieces of the same metals did nothing. Then, moving away from frogs' legs, in 1794, Volta did experiments to measure the electrical effects of bringing different pairs of metals into contact. He listed the metals in order of what he called the electromotive force. This was the first time anyone had listed electrode potentials. It was the first electrochemical series in this order: zinc, lead, tin, iron, copper, silver, gold, graphite, and manganese ore. In modern language, we would say that the farther apart the substance on this list are, the greater the voltage they will produce when brought into contact or used as electrodes in electric cells and batteries. For example, a zinc graphite cell will produce a greater voltage than a zinc lead cell. By 1797, Volta had completely proved his contact theory of electricity. He now knew that the key to producing what today we call a voltage was two metals connected by something moist like frog's legs. The moist connection between the metals did not have to be an animal. Connecting the metals by placing them in a cup of dilute acid was a very effective way of producing electricity. He formally spelled electrical conductors into those of the first kind. These were metals, graphite, and pure charcoal, and the second kind, these were substances we would now call electrolytes, such as salt water or dilute acids. An electric current would result when a circuit was built using two conductors of the first kind combined with one of the second kind. Alternatively, connecting the metals with paper soaked in dilute acid or salt water also worked. Volta said that in Galvani's work, the frog's legs had served two functions. They conducted electricity as conductors of the second kind, and also they acted as a very sensitive electroscope. An electroscope is a device used to detect electricity. Volta found that by connecting up more and more pairs of metal connected with a moist card, he could produce ever higher voltages, leading to significant electrical currents. And so the electrical battery was born. Volta used alternating zinc and silver disc linked by card or cloth soaked in salt water. In 1800, Volta described his result in a letter to Joseph Banks at the Royal Society in London. Banks showed the letter to other scientists and arranged for Volta's description of his discovery to be read out in a meeting of the society and then published. I continue coupling a plate of silver with one of zinc, and always in the same order, and place between each order of these couples in moist disc. I continue to form a column. If the column contains about 20 of these couples of metal, it will be capable of giving to the fingers several small shocks. Alessandro Volta, 1800. The battery Volta invented gave chemists a very powerful new method to study substances. The beauty of this device was that almost anyone could make one. Silver and copper coins were available to many people, as were other metals as iron, tin, and zinc. Within weeks of Volta's invention of the battery, William Nicholson carelessly built and used a battery to decompose water into hydrogen and oxygen. Within just 6 years, Humphrey Davy had built a powerful battery. With it, he isolated new chemical elements and deduced that chemical bonds were electrical in nature. Davy's discoveries of the new elements barium, calcium, lithium, magnesium, potassium, sodium, and strontium were all made possible by Volta's invention of the battery. By 1820, courtesy of Volta's batteries, Hans Christian Ørsted was investigating the relationship between electricity and magnetism. By 1821, Michael Faraday had produced an electric motor. Volta's battery produces steady source of electric current for the first time ever. All electrical devices depended on electric current. Without Volta's invention, there could be no modern technology. Volta's battery was an absolutely crucial invention in the development of our technology-based civilization. In 1819, at the age of 74, Volta decided it was time to hang up its capacitors, its voltaic piles, its electrophorers, and his administrative work at the university. He retired to a country house close to his hometown of Como, where he would spend more time with his wife Maria Teresa. They had 3 sons, Zanino, Faminio, and Luigi. Volta lived in Como until his death, aged 82, on March 5, 1827. In 1881, scientists decided that the unit of electric potential would be called the volt to recognize Volta's great contributions to electrical science.